perfectly adequate to form the railways with a series of straight lines and flat circular curves. When speed is increased, the need develops for a more gradual increase in radius of curvature r, connected with an elevation of the outer rail, so that the transition to circular curve became smooth. The clothoid makes a perfect transitional spiral as its curvature increases linearly with the distance along the spiral. The
Okay.
first order
Now
of
stay here and tell me that have you got this last line which which like just
hmm,
you have
this
read?
one, this one.
Yeah, this one.
Okay. Um, yes, I think so. So it just
Okay.
makes
Can
like this is
yes.
the curvature. The curvature
Yeah.
line increases with the distance. Oh, so I guess they're just saying that as the distance moves, so does the curves. Does that make sense? Like it's like a linear line. If you were to plot both of them, yeah.
Okay. That is like the curvature is linearly increases with the distance. Like as the distance increase, so the curvature also increase. But you're gonna like get the full concept of this line in the coming pages. But can you just look at the picture and can you just tell me what is the difference here? Like in the diagram. Look at this diagram which is here.
Yes, this one. So there's a linearly. Oh, just like it's more slowed, I guess, like the curve, so it's not as abrupt.
And the one like it's not a quarter circle, right?
It's not, no.
And then you can just look at the line which is a light slight line that shows us the quarter circle on the
Hmm.
same diagram. So that is the abrupt change, that is the quarter circle. And then we have this transition spiral,
Uh-huh.
which is actually quite different from the quarter circle.
Right.
And so it's take a lot of space, no? Like the
Hmm.
turn is taking a lot of space rather than just being flat circular.
Hmm. Yes, it is. Okay. Um, at first order approximation of the spiral is the cubic spiral. तो ये वाला, like this final,
Uh,
is
okay,
this the
okay. But
oh,
in this
okay.
line, I
Hmm.
was thinking that I should remove this line. That line, this line is as it's like the cubic spiral thing. Okay, but
Hmm.
I would like to go into the detail of this cubic, whatever this cubic
Hmm.
spiral actually mean here. So I would like you to
Right.
open the GeoGebra on the next step.
Is it? Oh, like should I just open it?
No, open the next tab
Oh, okay.
uh, and then the GeoGebra.
Hmm.
Oh no no, I'm saying that on the Google
Oh, like
Chrome you
left. Oh, okay, okay. Sorry.
yes on the
Yes.
next tab like new tab.
Okay, okay, okay.
Yes, and now like it is as a GeoGebra Classic. Yes.
Hmm.
So no GeoGebra.org ने GeoGebra Classic लिख दो आप and then
Okay.
Acha. Now write here any linear equation, right? Do you know what linear equations are?
Yes. Like,
Yeah, so you can write any linear equation here. Yes, okay. And now enter it. And in the second input, you can write any quadratic equation.
okay.
Okay, first tell me what's the quadratic equation? Like the linear equation is just a straight line. So what do
Mm.
you think? Like what quadratic equation would be? Like what kind of graph would you get after if you are trying to draw the quadratic equation?
It would be like those circular graphs. Maybe like a cone-shaped graph. Because a
Okay.
quadratic equation, it's like
Hmm.
it's squared, so that means that it's gonna be like it's like a circle like this. Oh, like this.
Okay, so it won't be in the negatives, like the y. It would be in the positives.
It can be in the negative. I think it no, it can be in the negatives. It can.
Okay,
Like,
so
should I make one or not yet?
okay, let's see then what happens.
Okay.
Write any quadratic equation. Don't need to make it a function. You can just
Yeah.
write like whatever. Just simply write down it. But it's in the negatives.
Yes, it can go in the negatives because if you take like a, I think when you take a negative number, you take the negative out. You just multiply it by like.
Okay, the input, you can give the input the negative numbers. Input can be like from the x-axis, you can take the negative numbers, but you will always get the answer in on positive y-axis, right?
Right.
So it
Right.
cannot be negative y-axis. The values of y, you will always get them, and those values will be on the positive y-axis. Okay, so what do you think about the cubic equations? What do you think the graph would look like?
Mm, wouldn't they be wouldn't they be like two circles? So it would be more like this. Like
Okay, so the circles are the perfect circles. Okay, you can say that like the two curves.
okay, two curves. Like this.
Yes.
This is a very bad drawing, but like this.
Okay, and yes.
Okay.
So you have like you have quite good guessing skills. Okay, so just write the cubic equation. Okay, so now can you please hide this linear and quadratic equation and just zoom into this quadratic cubic curve. So we're at the 6. Okay, so what is it? There is something which is like these curves. Are these curves like perfect quadricircles? Like we are
Um,
having two curves here.
not No, they're not.
Okay. So like the cubic is, so they were what they were actually trying to say in the slide. They were saying that these the spiral basically is the Euler spiral is kind of a cubic spiral. So here you can see that there's like if you want to change the lane or you want to go into any other lane or the any other street or something else, so you have to make, you are actually making these types of cubic turns, right? They are not
Yeah.
gonna be like perfect 90-degree turns. They would be like some kind of these kind of cubic turns. Okay, so this Euler spiral is kind of a, this kind of a cubic spiral, you can say that.
Okay, that makes sense.
Hmm.
Mm.
So, but I was thinking to remove this line because when a person will be reading it, so they
Mm.
will get confused like what is, why they are just relating it to the cubic or something else.
Actually, yeah, I think maybe, yeah. I think you can हाँ क्योंकि फिर वो they're gonna be like, what is this cubic spiral? What is
Yes.
cubic?
I
अच्छा चलो. So, and for the same reason, the spiral is used in ship design, specifying the curvature distribution of an arc of a plane curve while drawing a ship. To limit the g forces in a looping, sorry, to limit the g forces in a looping in a roller coaster, often a clothoid curve is used instead of a circular curve. This has been patented by Edwin Prescott in 1901.
Okay. Okay. So I guess so everything is clear here.
Yes.
Okay. So we can move next.
Okay. The Ural spiral, short history. The Ural spiral, also known as the clothoid or the spiral of constant curvature, is a mathematical curve that smoothly connects two straight lines while ensuring the continuous and gradual change in curvature. It was named after the Swiss mathematician Leonhard Euler, who made significant contributions to the study in the 18th century. Euro spirals found practical applications in transportation, engineering, and design, particularly in road and railway construction. The gradual change in curvature provided by the Euro spiral allows for smoother transitions between straight sections of road or railways and curved sections, reducing the discomfort and safety risks associated with abrupt changes in direction. In the 19th and 20th centuries, engineers and designers began to use the Ural spirals extensively in road and railway alignment to improve the safety and comfort of transportation systems. Today, they remain a fundamental concept in transportation engineering and are widely used in the design of highways, railways, and other infrastructure projects to ensure smoother transitions and reduce the risk of accidents.
Okay. So it was. So what did you understand from this all?
The Euro spiral, it is, oh, sorry. It's more of a, like the quarter circle, it's a very not abrupt curve, but it's a very fast curve. Whereas like the Euro spiral is more gradual, and that means that it'll make like a smoother drive, or it won't be as abrupt. So the safety will also be safe. It'll be safer to use, and it'll be smoother, like feel smoother and nicer to use um, than a quarter circle. And then it was made, or it was not made, but mainly the person who made it was Leonhard Euler. And a lot of engineers and designers use it in roads for roads and like train railways. Um, yeah. So like in
And
here, when we have like
yes,
big highways, इधर I mean उधर भी होगा highways, लेकिन हमारे highways जो होते हैं वो जैसे it's like multiple different highways on top of another, right? So उनके
yes,
अंदर
yes.
Euro spiral is used because it's a very gradual turn, which is good because if it was a cubic circles curve used, then it would have been a lot less safe and there would have been probably more accidents because people are going very fast already. So if you do fast like curve, pata nahi kya hoga.
Yes. So you have got this.
Yeah.
Okay, so we can go next.
Okay. Graphical construction of the Ural spiral. In this section, we will describe the step-by-step process for constructing the Ural curve, also known as the clothoid. The construction involves creating a series of arcs and circles with specific radii and lengths. The goal is to form a smooth curve with unique geometric properties. Begin construction by drawing a straight line starting from the origin 0, 0 and extending it to the point 3, 0. So
Okay,
I
so I would like you to yeah, open like on the new tab, the we have to construct the Euler spiral like this. Okay.
okay. Oh, sorry. 0, 0. Okay, I've done that. Now we do.
Yes. Okay, and now what you are supposed to do is that okay, I would also like you to write a formula in the input, which is kind of like a 1 minute.
Okay.
Yes and home है अगर लिखवा you can continue from the book till then.
Okay, okay. Okay, I've done it.
Okay, you have done with the
Yeah.
first circle.
Mm,
So next you have to take, as you have taken the arc length before, that the length of the line segment, that was 3. So now you have to take an arc on the circle, and that should be 3 as well, because this 3 is our constant, and the length will remain constant because we are keeping our arc length constant, that is 3.
okay.
Okay, and do you know what is curvature?
Mm, um,
What does actually curvature tell us?
like the degree to which something is curved.
Yes, so what did you say?
Is it the degree to for that something is being curved?
Yes, like the if um if like there is something. Okay, so I don't know either. I placed that picture in, I guess I didn't. So let me send you a snapshot, and you have to tell me that where the curvature is like greater, and where is there's less curvature. Okay.
Okay. Mm,
So that would be a curve,
so the
and okay, I'm sending you. Just a
oh,
minute. Okay, so I have sent, and it's on Skype.
okay.
Okay, have you seen that? Okay, I guess it's. Have you received it?
Yes.
So, by looking at this figure, can you tell me where the curvature is
I
more
think
and where is it less? It means that where the curve is actually more curvy and where is it not?
I think it's can you see the screen or no? Like the Skype screen or no?
You can share your screen of this so that I can see what you are referring to by the movement of your mouse.
Okay, so can you see it now? Like the Skype? Or-
I'm not seeing it right now, but I guess so. I will after a moment.
Okay.
Okay, yeah, I'm seeing now. Okay, so in this blue curve, where this curve is more curvy and where is it less curvy?
Okay, so right here along the ends, it's more curvy. And I would say maybe here it's less curvy because the curve is, it's, what is it called? It's less, what is the word? It's a gradual curve. It's a gradual curve.
Okay, so
It's a
where
gra
so if the curve is more curvy, we call it the curvature is more, like there is a lot of curvature. But if the curve is kind of flat, so we call it there is less curvature. So in terms of the language of curvature, so can you explain it like that? Like where is less curvature and where is
Here is less curvature because the curve is like flat, like you said. And then here there's more curvature because the curve is very abrupt, I guess, or it's
yeah, so
very
it is like
it's very sharp curve.
yes, exactly. So now I guess so you know what curvature is. Like if it's more curvy, it is like it has more curvature. If it is less curvy, it means that it has less curvature. So basically the curvature is the measure of the curviness in a curve.
Yeah.
Got it?
Got
Yes. Okay, so now we can move. So
Okay. So then okay, draw arc on the circumference of the circle starting. Okay.
the arc length, the arc, yes, from here, yes, the circular arc. Okay, you have to first click on D.
Okay. But it has to
Point.
meet the center.
Yes, you have to first like click on the point, the from where you wanna take the radius. Like so, first you have to. Okay, you are actually okay.
Like that. Wait,
No,
that's not.
first you have to click on the radius of this arc, like what you want to take the radius. Zoom it out. Yes, first click on D, then click on B.
Oh, okay.
Now click on B, and
Yeah.
no, you don't have to go back, you have to go forward. Yes, so now you can click on E. So you can actually increase, or like you can actually, okay, first change the colors of them as well. Okay, your arc length D is actually 2.98, which is close to 3. So I guess so it's fine. Okay, one more thing. You can lock this point D on this on the graph.
Wait, what do you mean lock it? Like
No, settings. Fix object. there is written fix object. Yes,
Okay.
so you have fixed it, and you can same do with the previous line segment as well, and with the point D as well, the point D which is at the center or the radius of the circle. Okay, you don't cross the settings. You just need to click on the other object and the setting.
Oh,
Yeah. Now
I
click
did.
on the line segment F. Yes, and now fix object. And similarly, you can do with any other point as well if you want to fix them too. So like if you want to fix this G perpendicular, okay, fix this point E as well. Yes. So because we are gonna make a lot of circles
Mm-hmm.
ahead, so then it becomes like
Too much. Very
okay, so it's
hectic.
better to fix them first before
Mm-hmm.
proceeding. Okay, so yes. Also, what you can do is color this circle blue and make it like reduce the width of this. No, not the width of the circle, but the width of the line. Um, yes, the opacity.
Oh,
Yes, thickness. Sorry. Yes, thickness. So, and make these curves, the line segment A to B also like change the color of that as well, and like make it shocking red.
okay. Oh, ये ब्लू तो नजर भी नहीं आ रहा है बेचारा.
Okay.
Let me just fix this really
Uh,
quickly.
that circle is fine like this because we have to make a lot of circles. Then
Okay, okay.
okay, so that line, the other circular arc D, make it red as well. Your all the arcs must be red.
Okay.
Okay, now we can proceed.
Okay. So I did this. Now at the end of this arc, we have to draw another circle with the radius 10 centimeters by taking the first tangent at the end of the arc and then drawing a perpendicular to that tangent. Adjust the perpendicular so that it will pass from the radius to previous drawn. So that it will pass from the radius of the previously drawn circle.
Yeah, so first we have to draw a circle and that radius must be 10. So I guess so we have done that, right?
Yes.
Uh, we have drawn the circle of radius 10.
No, we have not.
No. Okay. How there it is written that how we can draw that 10 centimeter, the circle of radius 10 centimeter is first we are gonna take the tangent at the end of the circular arc and then the perpendicular to that, and then we have to take the perpendicular to that tangent.
Okay.
And then on that perpendicular we have to draw a radius, we have to draw a circle of radius 10 centimeter.
Okay. Let me.
Okay, I guess so I should change this line from like by first taking, I should write here, when we will do this, we should take the okay for this. First, take the tangent at the end of the arc, and then by drawing a perpendicular to that tangent. Then, I guess so it's fine now.
Okay.
Oh, that's very smart.
Yes, because I
Because now you don't have to like
switch
go
back and forth.
to tabs.
Mhm.
Yes, switch tabs.
Okay, let's take the tangent. Okay.
Okay, you have to take tangent from the fourth toolbar, and it is the fourth icon.
Hmm.
And from here you will get the tangent command. Have you taken the tangent?
Yes.
Okay. Now you have to take a perpendicular, and that is toolbar, and the icon is 3. You have to take perpendicular from here, and
Adjust the perpendicular that will pass on the radius of the previous jump. Okay. Okay, I think I did it.
yes. And now take the perpendicular, and the tool on the toolbar, it's the third icon.
And oh, okay.
Yes.
So like instead of H, I should do D.
Yes, so D was the radius of the previously drawn circle, and now you have to take the radius 10, right? So
Right.
it would be at the middle or the center, the point D and E. So from there you have to start making the radius. Okay, so you can click at the middle of this perpendicular between D and E. But first take the circle command from the toolbar, and it is the fifth icon, I guess so. Yes, and you have to take here from the circle command and the second circle command. Toolbar, the fifth icon, yes. Circle, center, and radius, the second option, yes.
The center would be here, I guess, at 10.
Yes, here. So you have to click here, and they will ask you that what kind of radius do you want. So you can type here the 10. Okay. Oh, they didn't ask.
No, they didn't. There we go. Now they're asking. Okay,
Yes, yes.
radius. There we go.
Must be 10. Okay, so it's the perfect radius of 10. Okay, and it's crossing, and the circle is, I guess so. Can you please zoom this to the point E and press escape? Before zooming, press escape. Yeah. Okay, so that circle is not actually the radius, the circumference is not actually going through that point E. So you can adjust the point F a little bit up so that it will cross through this point E. You can move your point F a little bit up. Yes, now it's perfect. And also you can lock this point F here.
Okay. It is
Yes.
locked.
So now you can actually change the color of the circle, or first you want to make a circular arc of length 3, so you're gonna go with that. You can go with that, or if you want to change the color first, so you can go with that as you would like.
Okay.
Okay, so you can draw the arc length of the 3 centimeter arc length on this new circle now.
Okay. You said the arc length. So we did this.
Yes.
Okay. On the radius 0.3. On the circle with the radius of 10 centimeters, mark a point at the distance of 3 centimeters from its circumference. This point will serve as a reference to a subsequent arc. So, so we're just like here, I guess.
Yes. Yes, yes. On the circumference of this circle, you have to draw a 3 centimeter length. Okay, first I guess so make an arc length and then you can fix the object.
Like an arc.
Yes.
Okay, should I put the radius is like here, 5 or 10?
Oh no, at the 10th, because right now you are actually drawing the circular arc, not the another circle. First click on F, then E, and then G. Press escape.
Then
Yes.
E and G.
First F, then E, and then G. Yes, now you can change the colors.
Yeah.
And the length of this arc is 3. The
Mm-hmm.
K is the K. Oh, the K is 2.3.24. Can you adjust G? Can you adjust the point G so that it would be like quite near to 3?
Oh, it's 3 point, yeah.
Oh, you have fixed it. The G is fixed.
Okay.
So we need to unfix it.
Oh, okay, right. I was like, why is this not moving? Acha.
Yes. Oh, it was fine before. Yes, now it's perfect. Okay. So now you can fix this G.
Mm-hmm.
Now you can fix this G.
Okay, there. It is now 3.
Now it's 3, I guess. It is 3. The Actually we have to look at the length of the circular arc. And the circular arc is k here, right?
Mm-hmm.
And the length of the k is 3, isn't it?
Yes. Isn't that what we wanted?
Yes. So now you can fix the g.
Okay. Okay, it is fixed.
Okay. Now, first at the very beginning, our circle has the radius 20 and then we took 10. So
Right.
what do you think that the next radius would be?
5.
Hmm, no.
Mm,
Okay. So what was the reason, like what was the reason we took it 10 the next time?
um, I think it's because it was half of the
Half
diameter.
of the previous
Like the
circle?
rate. Huh?
Because it was like the half of the previous circle?
Yes.
Okay. So our first circle was 20
Mm-hmm.
and our line segment, our first circle was 20, the radius was 20
Right.
and our line segment was 3. So, okay, you can open the spreadsheet with it. No, not here in the GeoGebra. The spreadsheet can be open in GeoGebra. So you have to click on the right side and no, not from here. The triangle and the circle, the icon which has, yes, this one. Now click on these 3 dots. Yes, now here, yes, a spreadsheet. Yes, in the first cell, write, like in the cell 1, write arc length. Okay, first write in the cell 1, write radius. And then in the cell B, like the 1B, we can write the arc length, which is S in our case. Yes. And our arc length is constant, right? It is 3 only. Our first line segment was 3, then our 2 arc lengths were also 3. Okay, so now you can actually multiply the cell A, multiply by on the cell C. On the cell C, you can write the multiplication formula. Do you know how to apply the multiplication, apply the different formulas in the spreadsheets?
Yeah. Maybe I don't actually, because I
Okay.
don't.
Okay. So you can just check. You can just Google it. Write on the Google like how to write formulas in the spreadsheet. So you can actually make it more comprehensive, and you can write how to write the multiplicative formula or multiply formula in the spreadsheet. How to write the multiplication formula in this spreadsheet.
Okay.
Okay, so you can actually, you have just simply multiplied them,
Yes.
or you have applied the formula here.
Oh no, I
Maybe
applied
it's
the formula.
you applied the formula.
Mm-hmm.
Okay, okay. So now, I have you really applied formula? Like I didn't see because maybe the screen was lacking or something else.
Yeah.
Oh yeah.
Yeah.
No. It is like just simply you. Okay. Right. It's fine. So now you can see. Okay. Now what we are supposed to do is that in the book we moved the book back, and we have to in the book we have to move to the slide number. We have to move to the slide number 68. Okay, now read this point 5 once again.
Okay, now we draw the circle of the radius 10 centimeters whose center lies on the perpendicular. Why the circle of radius 10 centimeters? Well, the first the first radius we had was of 20 centimeters. Therefore, the radius is multiplied by the length of the arc equals to 60. Now divide this 60 with the total length of the arc, which is 6 now. So the answer will be 10. Therefore, we need to draw the circle of 10 centimeters. Okay.
Okay, now you can move to the GeoGebra back.
So we need to divide
By the total
by
arc
the
length.
total arc. Okay, so if it's like, so then the arc would be 10, I guess, because if it's 30 divided, oh no, 30 divided by 6, so it would be.
Okay, so on the D column you can write the total arc length, and then you can write like for the first, like the 20 centimeter circle, it was 3, and then you add the previous arc length and it becomes 6. And now when you need to draw another radius, so you will be having the arc length, and the total arc length would be
It would be 5. Or no, total arc length would be between these two 6. But if we added another one, it would be 9.
So actually, basically, the first line segment was also an arc length, right? If you
Right.
are gonna draw a circle so much big that it will be like from on the 3 centimeter the line segment, it would be having arc length as a line segment, because that circle is gonna be a quite big one. So how can you get the radius of that circle which have the line segment of 3 centimeter, which is basically having the arc length 3 centimeter, but that is the circle is so big, the radius is so big that it has proper line of 3 centimeter. Can you find the radius of that?
Okay.
So like we were dividing as we were going, and now if we wanna move back, so
We'd multiply.
yeah, so we multiply it, and we multiply it with like okay, we can actually zoom out first. Okay, I guess so. It would be quite like we are gonna first take the tangent, and the tangent would be to this AB line would be the exact x-axis. So it's not gonna make any sense for the circle also. So we have to like make a quite big circle so that we can get this line segment AB on as a arc of a circle. So I think so. We should leave this, and we should move like to our next circuits
Okay.
and complete our Euler curve.
Okay. We did this.
No, no, no. I okay. We have done this.
Okay.
So now, can you guess what we have to do next?
Okay, so now I think we're going to make another circle. That's my hypothesis.
Yes.
So we did this, the subsequent arc. Okay. At the end of the arc drawn at the previous step, draw another circle with a radius of 6.7 centimeters. The center of this circle must lie on the radius of the 10 centimeter circle. Okay. Hmm. Oh,
What
oh
is
no.
your total arc length, and what is your radius this time?
Okay, my arc length is my radius is 6.7 centimeters, and my arc length, I don't know yet. It doesn't say because we're just drawing the circle.
Okay. I guess so. First, we need to like uh, draw a tangent on the point G, and then we have to take a perpendicular from there, and then we will be doing the circle thing as we were doing before.
Like that.
Okay, have you draw yes, like this.
I don't.
First you will draw a tangent on the point G, and then you have to take a perpendicular from that point G, and then we have to draw the radius.
Okay. Okay. So first the tangent. And then we take the, and now we take the, so I drew the tangent for G.
Now you have to take the perpendicular to this tangent.
And then from here, I draw the radius.
Yes.
Okay. And the center would be here, I guess, or just at
Yeah, but you can adjust the center even after drawing the circle, but the radius must be 6.7. Oh, yeah, I guess.
Oh wait.
Yes, now fix these points. Also, you can hide the have you fixed the point F and G?
F and G. Yes. Now the circle runs through G.
I am asking, have you fixed these
Oh.
points?
Oh no. Let me.
Yes, fix them first.
Okay, now they're fixed.
Okay. Also, you can hide the previous perpendiculars and tangents.
Okay.
Not the current tangent,
Oh.
not the current perpendicular. Okay, so now what you are supposed to do here, like, what do you think that what is the next step now, as we are repeating the previous steps again and again? So what should be the next step now?
Making an arc.
Yes.
Okay, so
You can move this point G. Yeah, it's fine. Yes, perfect. Okay. Now you can change the color of this arc length and fix the point J. Okay, so also all these arc lengths, increase the thickness of all these arc lengths.
Increase
Arc lengths, thickness
okay.
of these arc lengths. Now zoom it out a bit. Okay, are you, by looking at these arc lengths,
I can see it forming.
Yes, what?
I can see like the circle forming, or like the arc forming.
Okay, so you are thinking that it's gonna be another one circle?
No, wait, I think it's like, no, like I see the arcs forming the curve.
Okay, so there will be no circle at the end with this red, like these arcs are actually forming a circle or not? Will those be a circle at the end or not?
I don't think so.
Okay, so what kind of shape it would be?
I think it'll just be a curve. Like I think it will just go like this and then straight.
Okay.
I think
So
maybe.
so your circles are reducing and you have this 3 centimeter arc length on every circle, and your circles are reducing and the radius very drastically. Like you have first the 20, the radius you had 20, and then you got the radius 10, and then you got 6.5. And what do you think that what would be the next radius?
I think it will be like 3 or 4.
Okay, you can actually calculate it. Take out your spreadsheet. So your third circle was
6.7.
Yes. And what was your total arc length at that time?
Oh, total arc length, not.
Okay, and previously your rotor arc length was okay. Just don't like that is keep it arc length, and then on column D you can write the total arc length. Okay.
Okay.
Yes. And then if you are going to draw a fourth circle, no, okay. When you are okay, yes, fine. So when you will be actually drawing the fourth circle, so what should be your total arc length for that? Because your arc length is constant. For the next fourth circle, the arc length will remain 3, right?
Right.
So if you are going to add 3 to 9, what would be your total arc length?
12.
Yes. So you can write the total arc length would be 12.
Okay.
Oh, no, for the next circle, which you have to draw now. The 9 was for the previous one. Yes, okay. So for the fourth circle, your arc length is still 3 because this is something which is constant and will remain constant in every circle.
Right.
So you can write 3 in the column B also. Okay. So now, and one more thing, our 60, this 60, we first like how we got that 60 was basically when we multiplied 20 with the 3, it was 60, right? So we divided that 60 from the total arc length at that time. It was 3, so we got 30. And so 30 was the okay, we got 30. And then what happened? Like,
then we had to
60 divided by 60 divided by 3, we got 10. So that's why our radius was 10.
right.
Now,
So
and for the next circle,
6, yes. 30 divided by 6.
so yeah, 60 divided by 6. And for the
Mm.
fourth circle, it was 60 divided by 9.
Yeah.
So for this circle, it would be 60 divided by 12. So your radius would be
Um,
when you will divide
it's
60
5.
when you will divide 60 with 12, you will get your radius.
5.
Yes, so you have to make the next radius, you have to take the next radius and it would be 5. 60 divided by 12 is 5. Okay.
Okay, now then I do, I guess, 5 times 3.
And it would be 15. I guess so we should like make this column C 60 throughout, because this is what we are dividing total arc length with, and that is our radius. Yes, because we are dividing and our 60 is constant, So we are just dividing our total arc length with this 60, and we will, and then we are getting our radius. Okay.
Okay.
Yes. So now what? So now you have to like draw another circle, and that radius must be 5. So you have to just repeat the same process and draw another circle of radius 5.
Okay, draw another circle. The radius must be 5. So I need to make a Okay, I need to make that tangent again.
Yes.
Can I hide the old one that I used?
Yes. Yes. You can hide the tangent, but let the perpendicular be there.
Okay. And then I need to make the perpendicular line. Okay, and now I will. Oh wait.
And now you can hide the previous perpendicular if you want to.
Okay. And now I make my circle. The center is here. Or no, the center would be
Yes.
5. Oops. Delete. The center would be 5. Or no, the radius is 5. Sorry. So this would be the center.
The center won't be at exactly at the point I, because we need to actually, because we can't move the point I as it's already fixed. So we have to make a radius, but it must be